In problem 11 on the exam, we have this circuit that contains a capacitor and some resistors and a battery. So as we can see from what the problem's asking, in this case the switch has been closed for a long time in the circuit, or after the switch has been closed for a long time, we then open the switch, and immediately after opening the switch the current through the 500 ohm resistor is 3 amps, and we want to determine the EMF of the ideal battery in the circuit. So this question pertains to RC circuits, so we can use some of the concepts we learned there. The first thing I have here, so the loop law for a circuit after the switch has been closed, or when the switch is closed, would be V minus IR minus Q over C from the capacitor equals 0. When the switch has been closed for a very long time, the current through the loop containing the capacitor goes to 0, which means that this simplifies to V minus Q over C equals 0. And what this says more conceptually is that the voltage across the capacitor will equal the voltage supplied by the battery. So we know that immediately when we open this switch, the voltage across the capacitor will equal the EMF of the battery. And then when we open the switch, we know that current will flow through the loop that I'm showing here. So current will flow through the capacitor and around the resistors as it discharges the capacitor. And using the loop law, we know V minus IR equals 0, or the voltage of the capacitor equals the current through the circuit times the sum of the resistances. We know the current is 3 amps. We know the sum of the resistances is 1500 ohms, and that means the voltage of the capacitor is 3 times 1500 equals 4500 volts. As we mentioned, this equals the voltage supplied by the battery, so the answer to this question is A, 4500 volts.